Okay, we're going to do a quick, this is Mike Wallant, ACI. I think you guys know me. I also have Dave Wisey, who's our gas sensor technical specialist here at ACI.
Good morning, guys.
And we'll just go through this one. When we get done, we have a Freon detection one. If we have time and you guys are okay with it, that takes about 10 minutes to go through because it's real simple. So we'll discuss that at that time. But any further ado, I'll get rolling because I know you guys are busy. So we'll get into ACI gas detection. And there we go. So basically, I think you guys know we offer CO2, all the toxic, all combustibles, whether it's for parking garages, chiller plants, hospitals, depending on what the sensor is. NEMA 4X is the enclosures. And we also offer the what we call our Q8s, which is explosion proof class 1 div 1. And I'll touch base with that more as we go on. So next screen is just a basic sensor and controller overview. We'll get into more details as we get down in the webinar here, and feel free to stop me at any time if you guys got questions, and I'll just quick go through these. The Q5 and B5. The Q5 is basically an analog and an RS
45.
Yeah, RS communicating. The B5 is our backnet version of the same toxic and combustibles. Q6 and B6 is the same as the Q5 except for their combo units. M controller is our smaller controller that can handle up to 32 sensors. And the Q controller is our larger one that can handle up to 128 sensors on one job, and can also be set up to have backnet IP if needed. The next sensor is our QIRF, which will be our Freon detection sensor. It's infrared technology, and I'll touch base on that on the other PowerPoint and get in depth on that. And then, of course, our Q8 explosion-proof sensors, and the B8, which is just the backnet version of it. And I'll talk about the features as we go on. Like I said, here's the M controller and Q controller, RS-45 communication. They can be 4 to 20 back, however you want to do it, Modbus. And the Q controller is the only version right now that you can do a backnet IP if you need to interface back to your BAS via that communication. The Q5s and the B5s, basically, here's the differences. Q5 is, of course, the analog version. You can do it standalone, or you can daisy chain them via the RS-45. Like I said, you can do up to 32 on the M controller, 128 on the Q controller, depending on the size of the job. And you can mix and match the sensors. It doesn't matter if it's CO, NO2, methane, hydrogen, oxygen. That all comes down into the programming on the software, which is included in our programs. The 24 volt VAC or DC. I'll let Dave talk a little bit down the road here on AC or DC powering and making sure that everything is square on the power sharing power transformers and stuff like that. The CO is UL 2075 listed, and typical lifespan on a toxic and combustible, you know, we have to put something down 3 to 5 years. We've got some of these sensors that CO wise that have been out for 7, 8 years. It all depends on how stringent the gas is in the area that you're measuring. If it's higher gas consistently, the sensor will wear and the length will come down. Each sensor comes with 3 programmable relays that are all factory set, and backlit LCD. Let's see here. We also have a buzzer or buzzer horn, 3 different tones on it. You can set internally. The box is NEMA 4X, which is really nice, and everything is password protected. On the backnet, our backnet sensors are MSTP, and figureable as master, slave mode, however you decide to do it. It also has different baud rates depending on what control system you're going to be landing the communication bus on. So What's the default for the baud rate, 38.4?
I believe that is
Yeah.
38.4. Yes.
Okay, any questions on the sensors here? None?
Can you hear me now?
Okay. We'll go into the B6Q6. Basically, all same parameters as the Q6 and or Q5 and B5. The B6 is the BACnet version. The Q6 is the Q6 is the analog or the RS-45 version of this. The only difference is that the secondary sensor, let's say you're doing a parking garage and you've got CO and NO2, and you've got the CO at 5 to 6 feet off the floor, which is recommended with the LCD on it, and the NO2, which is normally down around 12, 18 inches off the floor in most instances. That won't have the LCD. Everything will read back to the CO sensor, so you don't have to get down on your knees and look and see if there's an LCD. Everything will read and be controlled by the CO sensor on the Q6 version. Reason we took the LCD off was so we could be more competitive as far as combo sensors go. The one thing I think I forgot to mention, well, on this, on the BACnet, there's one addressable point. Is that correct?
Yeah. You know, by going next page, we'll give the differences between the two.
Yeah, here we go. Yeah, here basically the difference between the two. The biggest difference is on the BACnet side, right? There will be one point that's addressable, not two for both sensors. So that makes a big difference on your end. Instead of having, like, say you got 32 sensors that are coming on the BACnet protocol, you won't have 64 addressable points. You'll have 32 for both the CO and NO2. Does that make sense?
Yeah. So one address will cover both, you know, both the CO and NO2 sensor on the objects.
And the other biggest difference too on the Q6 is that the Q6, because of the combo unit, will be communicating, whether it's RS-45, won't have any analog outputs on it, whereas the Q5 and the Q5 and B5 will have, or the Q5 will have the 4 to 20 outputs as well as the RS-45. I know I'm rambling on here pretty fast. Questions? And I guess the other thing I would say too is if you have projects that you know of, and I know you guys are busy, you can send the plans to us. We'll lay out the whole system for you and give you the best scenario and do a quote for you, and get it back to you within 1 to 2 days for sure. And we'll do all the work for you if you need that, and help you guys out that way.
We did have one question. How are the MAC addresses set on the BACnet models?
The BACnet can be, on the B5s, they can be set either through the BACnet or at the sensor itself. It'd probably be easier to do it at the sensor itself because they all come out with the same MAC address of 4005. So if you have everything all powered up and try to discover, it's going to be kind of a mess to determine which one is which. So either one, yeah, the MAC address is either one. And then same with the device instance number. That can be done at the sensor or through the BACnet.
Cool deal.
And here would be the Q6 wiring detail. And
so internally, you know, from the main to the remote needs to be powered and communicates with the main. So it's RS-45 Optimux protocol, the manufacturer, you know, default to communicate between the two sensors, the two main sensors. So on the upper left, that shows the communication going down. On the lower right, That shows the internal communication. And then on the upper right, that shows where the power is coming from location to location to location. And then that the lower TB7, I believe it is, that's going to be your communication from sensor location to location to location back to your building automation system or, M controller. This is just a visual that makes it a lot easier to visualize how this sensor is going to be wired up without having to do the wiring. Questions?
We also send a network diagram, and depending on how the job is laid out, from point-to-point wiring from the sensors, depending on whether it's Q5s, Q6s, B5s, B6s, back to the controllers. We also do that in addition on each project too. This is just a standard way of mounting parking garage, your typical Q6, B6 right here, NO2, CO sensor down low, CO at 5-6 feet. Over here, it all depends on the application. If you're looking at a loading dock, for example, and the semis that are backing in have stacks that blow the air up straight up in the air, you may want to mount your NO2 sensors 2 feet off the ceiling, just in case. And if they're semis that have the floor type exhausts, you may need both, or maybe you need the floor, just depending on where the exhaust is coming out. The other thing we recommend too is on the stacks is maybe putting an override switch right here at the CO sensor, because sometimes with these new trucks, the emissions aren't enough to set off the sensor as far as NO2, but the diesel fumes that go up start filtrating down because they're heavier, and people start smelling the fumes and thinking the sensor's not working, and which it probably is. There's just not enough NO2 in the air to change it. You can hit the override and get the exhaust fumes or the diesel fumes out of the area. Just an idea for that too.
Yeah. So that, these are some of different recommendations for mounting, the NO2 sensor. They're, some people say it should be mounted high. Some people say it should be mounted low. These are our recommendations, but when it comes right down to it, the building codes of your municipality or state always trump where the sensor should be mounted.
Some accessories, we got the sensor guard. So if you do have a parking garage and you need to protect the sensor, depending on how and where it's at, that's basically each job selected. We found splash guard. Splash guard helps protect the sensor in some washdown environments. For example, if you're putting a CO sensor and an NO2 sensor in a firehouse or an ambulance, and they're cleaning, washing down the vehicles or the fire trucks, and the sensors are close, sometimes it's wise to put a splash guard in to help save the sensor, because they don't actually know what that product is on the wall, and they just hose it down. So it's just that's a good idea for those two type applications. And a duct mount kit, if you have to put it in a duct mount, we also have that apparatus as well too. Let's see here. Replacement sensors. It's kind of a neat feature. Let's say you got a job out there, and you've got, I'll just use the Q5s for example, and you got CO and NO2, and let's say after 5-6 years, you go out, you do a bump test on it, and you don't believe the sensors are working correctly. You don't have to replace the whole unit. All you have to do is replace this little microprocessor board in there. And basically what that is taking 4 screws off the front, pull it off, 2 screws on the microprocessor board, pull that out, put the new microprocessor board back in, make sure everything's powered down, put it back in, put your screws on top, fire it up, everything's pre-calibrated. And what we really recommend is just quick doing a bump test, and away you go. It should work pretty seamlessly. We've done quite a few of those in the past. Any questions on this?
So we do offer a gas calibration kit. This is one of the big questions that we get asked is, do we handle the calibration gas? And yes, we do. So we put this gas cal kit together. It includes the 0.5 limit liters per minute regulator, the adapter that goes from C10 to CGA 600, the poly tubing, and the carry case. The calibration adapter that goes on the front of this Q5 or Q6 is sold separately because this can be used with our Q8s, which is an explosion proof, and that requires a different type of adapter. So like I said, the zero gas and the span gases can be purchased through us. That is on the data sheet. We'll have a drop ship directly to either your job site or your office. And it makes it a lot more convenient just to order everything on one PO, and it comes at one time.
Okay, I'll keep moving. Here's just a sheet to kind of give you an idea of where the sensor should be located in reference to above finished floor or below the ceiling. And there's many more than this, but this is a good representation of gases and where they should go. And the square foot of coverage too. Like CO and NO2 are 50 foot in radius. We can get that information to you if you need it, but square footage, pretty standard across the board. These are just some of the typical ones. All right, before I move into the programming of the software and stuff like that, which the software is included on every job, any questions so far on the products themselves? Okay. Now I'll let Dave talk about some the programming of the software that comes with it.
Okay, so the MView programming, that's going to be a program that's included with the M controller. The M controller can be programmed either using the onboard keypad or the software. I strongly recommend using the software. It's a lot quicker, a lot more intuitive, and it's just easier to use. It'll be easier for the installers to get it programmed and working than trying to enter everything by hand. So when you first open it up, this is what it's going to look like. The everything is done on the outer buttons. The sensors are entered. Next, please. Right here, so you can determine what the sensors are going to be. In this case, we're using, let's just say the Q6 with CO and NO2. There's going to be 4 locations. When you enter the CO in here, or the Q6s, the main is always, remember, going to be even. When you start at 0, the odds are going to be 1. So we enter the gas type, CO and NO2 parts per million. And then our next step is to set up the relays on here. So we're going to use 2 relays. Relay 1 is going to be for our low alarm. Relay 2 is going to be for our high alarm. We're going to set it up as non-latching and voting, which simply means that if any of those sensors detect a level, it's going to turn the relay on.
And let's just say that you've got CO, NO2, or even hydrogen or oxygen on the same loop. The voting will enable the relays that are on there. If any one of those relays go off, even though it's not CO or NO2, it'll send the alert back to the relay.
So then the next step, we're going to assign the sensors to the relays. So we choose relay 1 up top. That's going to be your low level alarm. In this case, we're doing 35 parts per million to turn on CO and 1 part per million for NO2. And our off limit is going to be 25 and 0.8. And that's going to be our first alarm level. And we're assigning that to relay 1. So it doesn't matter if either the CO or the NO2 reaches those trip levels, it's going to turn relay 1 on. And we do the same thing for relay 2. Higher trip levels, 50 and 40, and then 3 and 1. And that will turn relay 2 on. So, then relay 2, your high alarm, that could either be another fan, that could be a horn and strobe back at the superintendent's office, or even, set up another relay 3, that could be a dry contact to the fire alarm panel.
Right. And the nice thing about these programs too is after you do a job, let's say you have 10 CO and 10 NO2, and the next job you may have maybe 15 of CO and 15 of NO2. If you do a save as on this, all you have to do is bring that up if you want all the same parameters and just add 5 more sensors, and that's how easy it is to program as well. So on the programming, questions on that. And the other thing we offer too is like the first job or 2 jobs, we really recommend once you get everything, we'll know what the products are that you got. Call in here and talk to Dave about the program, and he'll walk you through it. It'll take about 5 or 10 minutes, and probably won't even take that long, and you'll get the hang of it and be on your way. Some of the free services we provide, of course, we touch base on network diagrams. We'll look at the floor plan specifications. We'll mark floor plans up for you, sensor locations. And the other thing too is if you guys have contractors that are installing, a lot of specifications now are requesting certified installers on the projects and their specifications. And we can actually, we've got some videos set up that we've done for other distributors and their contractors. And if they work with Dave, we can get them certified to install our products to meet those specifications as well.
It's very quick and very easy. Usually takes less than an hour to do everything. The videos, total of 5 videos, about 20 minutes. The guys then just sat down in a Teams meeting, and I have a PowerPoint we set up. We go over, the different wiring options, the sensors again, and then how to program, how to do that, set up a a sensor diagram, and then how to do everything.
So the next screen here is just basically a network diagram, real basic, shows terminal blocks on a Q6, CO, NL2, and coming back to a Q controller. Typically anything over 32 sensors would require the Q controller to do that. And then in this case, there's a back box, which is the BACnet card that needs to be put into the Q controller, and that will give you BACnet to the BAS IP. So if you need to convert that, you'll have to get a converter. Let's leave that up to the contractors. Here's another simple one. Let's say the Q5, COs, NOs, oxygen, hydrogen, propane sensors. It doesn't matter. All the wiring is going to be all the same. Back to an M controller, and then of course the relays out to any type of fans that you want to turn on, and so on and so forth.
What is the connection type to the controllers to configure through the software? Is it going to be through Ethernet or USB to 485?
So for the M controller, which the adapter is included, as of right now, it is a serial to RJ45, but that is in the process of being updated. That will be a USB connector and cable from your laptop to the M controller. The Q controller, everything is done right on the touchpad, very easy to use. That's one of the videos that I did on how to program an M controller. That can, we can send those to you if you're interested in seeing how that's done.
This would be a typical QEL certificate for your contractors. This would be their name, or well, this date, but we get their name on the certificate. We've covered most of this. Okay. Okay, that pretty much takes care of the toxic and I know I didn't touch base on the explosion proof sensors. If we can touch base at that at a later date if you guys got questions. Those are pretty standard too. Any questions right now on this? Okay, do you guys have time to go through the Freon chiller plant presentation? About 10 minutes?
Yeah, we do.
Okay, let me try to bring that up here. Okay,
Can you see that?
you guys see this? Can you guys see the QARF?
No, not yet.
That.
Right here.
Yeah, right there.
See it now?
No, we just see your name.
Okay, what is that? Yeah. Okay. Share screen. There.
There, we may have it now.
Yes, we can see it now.
All right, perfect. So this is our Freon detection system for basically chiller plants. And QIRF is our refrigerant detector. I'll, of course, get into details here in a couple slides on that. We know why Freon is needed in chiller plants. We abide by the ASHRAE 15 for the most part. For refrigerant detections, and we'll have some network diagrams. I'll really explain how the system goes to works together here in a few minutes. QARF refrigeration detector. It's infrared technology. Sensor has a lifespan of about 13 years. It covers about 7,500 square feet. Comes with 3 relays, an LCD. All preset. And the cool thing about this is, let's say that you guys got a QIRF on your shelf and you got a customer comes in and say this is set up for R134A and you need R510. Well, you don't have to send that unit back or order a different one. You can just power it up and change the parameter right on the screen to an R510. We've got all the Freons downloaded into the microprocessor. And if you have any questions on that, you can call in here and we can walk through it with you in about 5 minutes. So it also comes with a 4 to 20 or 2 to 10 analog output besides the RS45. It can go down to minus 49 degrees F. A lot of times you're going to see specs where you might have 2 chillers in a room and they're both the same Freon. Well, you don't really need, depending on in the same mechanical room, you don't really need 2 sensors. You just put one in between and it covers 7,500 square feet. So you're covered. You don't need 2. However, if the chillers are different in Freon, say 510, I'm just using numbers, R410, whatever, you would then have to have 2 different Freon detectors for your chiller room. Here are just some of the Freons that we get. I know there's some new ones that have come out recently, and we're updating our sheets as we speak on those too. But if there's a Freon that you don't see in our, just call us. 99% sure we've got it covered.
Is it a Modbus or are they looking into BACnet communication?
They are looking into BACnet, but right now it's just an RS-45.
Yep, Modbus RTU.
Yeah. Basically the same controllers, but to be honest with you, the only time you really would need a Q controller is if you need to interface back to your BAS with BACnet IP. If you don't need to do that, the M controller is a lot less expensive, and as you'll see in a slide or two coming up, and it can handle up to 6 QRS, which would be a pretty large mechanical room if you get 6 of those covering 7,500 square feet each. Some of the accessories here, override switches, depending on which controller you're doing. M controller, you would have to have an M switch, Q controller, Q switch. We lay that out for you. We'll help you with that. And then the strobes, we've got all kinds of different strobes and horns. And the strobes we offer do come with horns already in them. So I think this network diagram right here kind of explains everything that's going on. Let's say you got the 2 chillers there. You've got one, they're both the same Freon. You've got one QIRF in the middle there, communicates back RS-45 to the M controller. We have an override switch in the room and outside the room, and also a strobe outside the room and inside the room. We also offer a remote switch for reset if you need to override. Now the M controller, I've seen it in different places. You can mount it inside the room, outside the room. That will display what's going on in the Freon sensor, so you don't have to get down on your knees at 12 inches off the floor and have to look at that. Every code is a little bit different, whether it's mounted inside or outside. So that's usually on a local base, what the code says. Does this diagram?
Horns and the strobes universal? Can they be used by any digital output?
The horns and strobe, that is, they require 24 VAC or VDC to power. Yeah, they're pretty much a universal. Any relay will turn them on or off.
So here'd be just the same scenario. Let's say that you got, this shows three sensors on a QIRFs coming back to a Q controller. The reason we did that was because this particular company needed to have BACnet IP back to their BAS. So we got to have the Q controller with the back box card in it. And now we use the Q switches instead of the M switches because it's for the Q controller, it's just wired differently. And then a strobe inside and a strobe outside. So basically the same concept, just different controller and different way of communicating back. Does this diagram make sense as well?
Seems pretty cut and dry.
Yeah, and the relays then are tied in through whether it's the M switch or Q switch, are tied into the exhaust fans in the mechanical room. So if something happens, they hit the switch, it overrides, and you know how that sequence of operation works. So installation, also recommend is you mount the QARFs about 18 inches off the floor. I think that's pretty standard. Oh, the other thing, being it's infrared technology, allows us, there is no sample tubes with our system because the sensors are so sensitive. I got a company here in Indiana, it's about 80 of these, and they did some testing and they were up to 75 feet away and dropping some Freon just to do some testing, and the sensors were picking it up almost simultaneously. That's how sensitive they are. So just to give you an idea on that too. Maintenance, the annual type bump test or whatever you guys, your customer wants, if it's 6 months, a year, whatever, but we do recommend that at least once a year that you guys go out and do a quick bump test. And right on the side of the sensor, right here is your test port. So, and the QARFs all come pre-programmed. They're pretty much all the same with their same relays, set points, and spans on the Freon as well. In a nutshell, that's pretty much it. Questions on this system, and once again, we'll help you guys lay it out. Questions we'll ask are, what type of Freons are your chillers? What's the mechanical room? Or if you get a mechanical room, send it to us. We'll lay it out for you. We'll ask you the questions. Do you need the BACnet option, or is the Modbus coming back to the BAS, or is it standalone? Do you want it inside the room, outside the room? Those are just basic questions that we would ask you guys. So I know that was 40 minutes long, a lot of talking, but that concludes the two presentations. Questions, guys? And the other thing is we have a lot of stock in all these sensors as well.
Yeah, like Mike was stressing earlier, if there are any questions from the installers out in the field, they can call me anytime. I'm available 7 a.m. Central Standard Time and done at 4 p.m. Central Standard Time. So I'm here all day to answer any questions, help wiring questions, programming, even laying out.
Yep.
So, there's always going to be somebody here to answer the questions that the installers have.
We actually recommend the first job that somebody does is to call in and just ask the very basic questions and make sure everybody's on the same page. And once they start doing it, we've had extremely good success with a lot of contractors doing that. And they actually come back to us and tell us how easy our systems are to install as well. So.
Awesome. Thank you, gentlemen, for your time. And it was a great presentation.
Thank you very, very much. And like I said, let us know where we can help you guys out.
Absolutely. Thank you, gentlemen.
You bet. Have a good day, guys. Thank you. Thanks, Jeff.